All right, one last problem, rotational statics. So what we want to do is we just want this thing to stay put. What we have is a mobile, right? We have a mobile. We've got a bar that's suspended from a string, and that spring is right here. There's a half a meter to one side and 1 meter to the other side because it's long. And we've got some stuff hanging on either side. We've got 2 kilograms on one side, 5 kilograms on the other. So that's good. So all we want to do is we want to balance this thing out by pushing this thing at some point x. We don't know exactly where we should put that 1 kilogram so that everything balances out, but that's what we want to find out today. How do we do that? We do that with rotational statics. So we do that with rotational equilibrium. We do that with torque balance. So that means that all of the torques on this particular case have to add up to 0. Now this is a simple torque problem because each one of these guys is perpendicular. So the radius comes from that pivot point to the spot where it's, or the distance goes from here to the spot where the weight is connected. And the direction is going to be straight down for all of them. We've got a horizontal bar. Horizontal is perpendicular to vertical. That's a rule. We've seen that rule before. Horizontal is perpendicular to vertical. So we want to use that rule and make sure everything balances in this problem. How do we do that? Well, we just start substituting because the torque, if things are perpendicular, is just the distance times the force, basically. So it's not really the distance, it's the displacement. And why do we care about that? Because this is a negative number, right? That's minus 1 meter. So if we call this guy 1, this guy 2, and this guy 3, then we have at minus 1 meter, 2 kilograms, and because it's a force we need 9.8 meters per second squared. That's looking good. Then we do number 2 over here because we have all the information for it, and that is 1/2 of a meter times 5 kilograms times 9.8 meters per second squared. Plus for 3 we have a distance x that will end up being in meters, but it's not now, times its mass, which is 1 kilogram, times 9.8 meters per second squared, and that's all equal to 0. So let's see, what's the first thing to do? Well, you may notice as well, that there's a 9.8 sitting around in all 3 terms. Get rid of it. Get rid of it. You don't need it. Get rid of it. We can also get rid of these kilograms if we want, or we can keep them. Let's just keep them. We can get rid of them later. They're not that burdensome. So that means we have, if we multiply all these things out, minus 2 kilograms times meters plus, right, minus 1 times 2. And here we have 1/2 times 5, so that's 2.5 kilograms times meters. Plus, this is a positive number, plus x times 1 kilogram equals 0. Let's keep this guy on that side and add the other stuff. So we have 1 kilogram times x is equal to, we move this guy over here, we change his sign, so it's 2 kilograms times meters, minus, because this one was positive, it's now negative on the other side, 2.5 kilograms times meters. Now let's get rid of those kilograms, and if we divide through by 1, everything's easy. So we have x is equal to 2 minus 2.5, which is minus 0.5 meters, which is right in the middle of this bar. So the 1 kilogram thing should be way over here. Number 3 should be hanging there, so that everything balances out. That wasn't so hard, was it? Just do a lot of substitutions because the torque is equal to RF, or whatever we called it. Are you feeling happy or are you feeling sad? I know you're feeling sad because this is the last example for the semester. And that kind of gets you right here, doesn't it? But don't worry, don't worry. I also have a homework review to go over, and we get a test after that. And so that should keep you all warm inside. All right. So I'll talk to you later, and I hope everything's going well and all that fun stuff. But I mean, pretty soon you'll be able to sit around without schoolwork to do. I guess that'll be better than nothing. All right. Although it sounds a lot like nothing. All right. Bye now.